Hi, Mike. Okay, it looks like it's going. Hello! Hopefully that's not clipping too bad. Okay, let's make sure our stream is up and going. Let's see. Um, Stream health. Okay, we're doing good. Okay. So we don't currently have anyone on, so I guess I'll make an announcement for the sake of making an announcement. Like, clean out that whiteboard. Um, So announcements. I'm gonna try to do a more regular schedule. I may start dual streaming to Twitch and YouTube. And Wednesdays we're gonna do game night. Tektronics has a lot of cool digital design games, and we're just going to explore them. And they're just I think they're a great way to learn digital design. And this one right here, Shenzhen IO, is great because it forces you to read documentation, which is like any digital design job is just reading tons and tons of documentation. So that's basically what we're going to be doing, is reading tons and tons of fun documentation. Everything's going good. We're going to dive in. I will try. I guess it's probably gonna be like maybe an hour plus video. Wednesday, or today's Wednesday. Friday we'll look at Vitus AI again. Saturday I want to relook at doing SHA 256 on FPGAs, and then we can go talk about the schedule later. Okay, so I haven't done this in a while, so I'm going to have to read through the documentation and figure what's happening. But first, let's go figure out our first puzzle. Our first puzzle is the virtual reality buzzer. Okay, do my someone sneak up on me. A simple vibrator attaches to a VR headset so it can be felt during the most intense sequences. Connecting to a radio controller, I could place the button outside of my study and buzz me when she needs me. No chance of me. What do you think? Congrats, David. Okay, so let's open it in the concept CAD. Let's go ahead and just do a new design. Open the design. Okay, so we have our information, right? And then the verification that we then can run. We have different buses. Rotate that. Here. So all we do is care about the radio RX. So let's see. Radio RX is a non-blocking X bus input connected to a radio receiver. Buzzer is a simple output connected to a electromagnetic buzzer. When the data is received, over there I read it and execute the corresponding command in the following table. So if 1, we're going to go into a state, and 0, we're going to turn off. 1, we'll go to a state where we buzz every once in a while. So if we hit simulate, right? Okay. Pause. So we don't have these parts recommended. So basically you have these little processors. Reset. ACC is a thing. So this is the MC4000. So if we go here, right, and we do MC4000, I think it's just this one, right? So we have a single bus and an X bus. And okay. So what we're gonna do is that and that, right? So all I want to do is let's just do a 1-to-1 ratio. So we need the commands. Do commands. Okay. Copy the value of the first operand to the second operand. So if I say move x0 to p1, can we simulate this? Part not sleeping. Okay, so we do need a sleep. We need a sleep Um, those two are definitely wrong. Okay, let's try sleep one, right? Um, oh, so it moves into a register. Um, so integer register are pin. We need to figure out a little bit more of what's going on. Those are cool conditions, but test instructions. How did they do up here in this example, right? This what? Okay, if we reset and we do a move 100, right? Like the example. Um, was it just oh, it's an analog output, right? So if I hit reset, so okay, I think this is an analog output, right? Simulates. Oh, it's an analog output. That's terrible. So P1's an analog. So basically what we want to do is we want to move X0 into I know you expect a register. Um, what registers do we have for this device? Um, what registers do we have? Okay. Um, so let's move ACC here, and let's do a quick if ACC is. What are some examples? Good to do. Test the value if the first operand is equal to the second operand. I need an example of a test so I can understand what's happening. Okay, let's see. Sorry, I'm a little rusty at this game. Okay, if it's true, it does the plus. So what we want to do is we want to say test equal ATC to 1, I guess. And if this is true, we're going to do move um 100 P1, right? Okay, and can we do a minus? Conditional execution page 2. Where is conditional execution? Conditional execution. Okay, so if we do like a minus, right, and do a move 0 into P1, right? Let's see. Oh, look at that, look at that. So reset. So to make this simple, we need a state, right? We need to be if like right, test if equal. Or can we do a greater than or less than? well, we can do test x0 is 1, right? Then we're gonna do a plus ACC, or move a 1 into ACC. Test equals x0 is 0, right? We're gonna move a 1 in, or a 0 into ACC. Oh, so the test is 0. 1. What happened here? Okay, reset. Oh, so it's only stored for what, a single clock cycle? Well, that's rough, mate. Changes that one, so we would have to move it and store it. Ooh, that's rough. Maybe we could use basically a latch of we move it to that. Yeah, we may need two, or we could try the M600, which has more instruction space. So yeah, let's go ahead and we're gonna try this guy. Yeah, sure. So what we're gonna do is we're gonna do a sleep X on X0. It's gonna be our last instruction. And first we're going to move X0 to that. And then test equal if that is 1 plus ACC, or move ACC1. Oh, sorry. Gotta do that the other direction. 1 ACC. Test equals test equals that equals 0 plus move 0 into ACC. Now, if ACC is high, test. Can we do nested? That is a great question. I think so. I think it's just how it works. So test equal if ACC is 1. We're just gonna move 100 into P1 and minus move 0 into P2. P1. Okay, sure. Let's see what this looks like. Hearts are not sleeping. Uh, okay. So apparently we're just gonna do a sleep one. Apparently I don't know how that works. Simulate. Okay. So now we just gotta get this fun toggle reset. So if I say if test equals um so I have to think about how this and want to say text equal p1 is 100, right? So if 100, we want to make it a 0. Otherwise, we want to move we want that. Oh yeah, 100. Yeah, 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 yeah. 100 p1. Let's do this. Okay, apparently I don't know my software. That one, that one, that one. Oh, okay. So where's this excess? Okay, so like it switches, right? So if we hit reset, right, and if we do a minus there and a plus there, what do we get? I'm curious. I'm curious. One there. Well, that is false. Okay, let's reset. The plus 100 here. You can't take 1,000. Too sad. Okay. We can't have 100 on all of them, or it's kind of pointless. Okay, let's try this again. Boom. Yeah, yeah, yeah. Get to one. Move one. That's true. I don't know why it does that. Why does it switch? Like a conditional test environment. That seems weird. I don't know what the documentation would say with that. We could try uh, nested conditional nested conditional execution Shenzhen. Okay, let's see what we got. Uh, A always when A is true, B when both A and B are true, are all true is interesting. When any of A, B are false, um, E is false. So the conditions start. Okay, so what's happening is when both A and B are true. So when both A and B are true, like we say when both these are true. So when both of these are true, we'll do that. Wait, this is if any are false. Ooh, what do we do? What do we do? Do that, that there. So when both of these are true, that will happen. Oh, let's go back. So both are true. Okay. And both A and B are true. Yeah, I'm not really figuring this one out. That's a weird thing. Okay, so okay, there's no way to see the conditional of this one. It's kind of annoying. All I can think is if we stick I'm sorry, stick a plus there. Okay, so it's saying, can we properly test that? That's a good question. Reset. Um, let's see. Can I test those? Can I test the outputs of the value? Uh, okay, so question then becomes, so we can't test that port. That's the only thing I can think of at the moment is we can't test that port. Um, so let's see, if I say 0p1, does that do anything? Does it need to be that direction? Okay. Yeah, it's weird. It's like you can't test those ports. Let's see. We do send then uh test equal P1 output. Okay, it looks like we need to do software. Okay, so we need to save it. So basically what we're gonna do is reset. Let's try this again. We're gonna say we're gonna test compare, right? Is that the command I want? Um, let's try that. Man, this is probably like hardware better than software. So we want to do test compare if that is 0. If it's equal, we want to move ACC to 0. Um, can we do that? Can we do like a little less? How would we do that? How would we change I mean plus, so if it's above, we want to say move 1 into ACC. Oh no, we can't you could wrap it around. Like -1. Um well, let's just do the naive approach first and see if we can come up with something interesting. 1 move. How about this? Voila. Um test equals if A1 if ACC is 1. We do, yeah, let's do test compare. Compare. If ACC is 1, this is true. Negative. Negative, we would move 0 into P1. Equal. We we want to do the equal one first, right? Oh. So yeah, let's just go for it. So we're gonna move 100 in P1 and move a 2 in ACC. And if it's a plus, we're gonna move a 0 P1 and this is plus. We're gonna move a 1 in the ACC. And then we're gonna sleep 1. Let's see how this works. Oh. How did that happen? Advance, 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 advance. Okay, we're in zero land. Zero. Oh, okay. So if it's zero, leave it zero. Okay. Simulate! There we go. That was interesting. Power usage. We were high. Fun. Product cost. Good. Lines of code. Good. So it looks like we could have had less power, but you know what? We're good there. Screen design electric game. Open in concept CAD. New design. Let's open the design and see what happens. We have info. Are we just supposed to play around? Back home. Concept now. What is this? It looks like they just want us to test out the custom LCD panels. Open design and what is that? LX700. LX. Uh, okay. How do we trash something? Ah! I don't know how to do this stuff anymore. Okay, let's see what we got. Memories, geometer. Yeah, switch. That's great. What's a LX? I wonder what the N4 N4 is that a okay. We put this here, right? Okay, So if I do this, right, show wires. Okay, 4 non-blocking X-pin buses. What's the LX LXR? Ah, the LX100R. The LX1. They're like LEDs. Lights. Ah, we have no documentation on these LX100s. Let's see. Shenzhen LX100s. Okay, we're just gonna assume that um okay. Okay, let's see. Throw down one of these guys, right? No, we want the other one. So we're just going to move X0 into ACC and sleep 1. um, Simulate. Um, to this guy, right? We're gonna move here in ACC. Test equal ACC is -9999 minus move ACC into bad. Sleep 1. Simulate. Is that like we have a 2? We let go, we get that. Okay. That's the D press. J, K, M. Okay. Now, is this the LXC? It's just so interesting. LXC 100. There's LX, oh, LX 910. Gotta pay attention. It's really interesting how this game has such a nice little thing. Okay, so we can write turn on segment, turn off segment. Is there better like information? Um, Yeah, I don't know. This is LCD screen. Um, oh, um, so touch segment. No, we don't want to do that. So we're just gonna move that into X3. Let's simulate this. Restart. What happens if we reset? What if I move 999 in there? Is that supposed to turn on all the segments? Uh, Confusing me. So that's definitely segment one, I guess. Hmm. Yeah, I guess I'm quite confused. Um, Indexing for segments usually left. Okay, using the direction included in the game. Yeah, I guess we're going to move forward, man, because this that one is going over my head at the moment. So let's go back. Right, right. Let's go see what else we got. Little help. Okay, let's go see what we got here. X and Y are simple inputs connected to a joystick. Maybe are simple outputs connected to buttons. The non-blocking connected to is an output connected to a radio transmitter. The game data is received over the radio from the game console to respond with the following three data values and make sure that responses. Okay, when a data packet is received over the radio, um, respond with the following three data packet, making sure to respond to the most recent input values. 0 of A, 0. What? When a data packet is received, you can respond with the following three data pack. Oh, okay. So, we always want to respond with X, Y. Okay, so if we go to verification, right, we go. Um, so what you want me to do is, do we have enough? Um, X, Y, input A, input B. Our simple inputs. So, right? Um, ooh, how will we do that? Add a bridge. Oop. Okay, we gotta scoot that over here at a minimum and add another bridge. And up. Boop, boop, boop. Oh no. Okay, there we go. This is great. This is great. Um, Not really a way to respond well for that, is there? I mean, we could try to um move this, rotate it. We Okay. So let's just do our classic thing. We're gonna move x0 ACC, right? And test equals if ACC is 0, we're going to move P 0 into x1. Otherwise, move P, no, 0 P1 into x1. Sleep. Sorry, sleep 1. So we're just gonna say move 0 into x0, sleep 1. Move 1 into x0, sleep 1. Yeah, it's something like this. So step. Oh, we want to do a sleep x1, sleep x1, I guess. I guess we want to move x One into ACC. Okay, that's how we're gonna do it. Okay, so this the buses have to be accessed. So if we just um that's kind of tricky. But yeah, sure. There we go. We got a little IO expansion here with the buses. Okay, cool. So we're gonna restart. So let's just try to get the first ones going. Um, so in that clock cycle, we expect that. One, yes. Um, so what would we do here? We would do, so we're going to be waiting on that one. So we're going to move RX, or what is that? I think it's X3. We're going to move X3 into that. Um, if that equals -1, then uh, we're going to move a 1 into x0, and then we're going to move a x1 into x2 and move x1 into x2. And then we'll sleep 1. Sleep 1. Okay, let's see. That okay, so reset, and then minus, we're gonna move a 0 into x2. 0. Am I hmm, how are those sleep commands supposed to run? Okay, so I guess so sleep x0. Um we mix them up. So where mouse go? So we're gonna reset, remove this, and simulate. So now we just need this final conditional thing. Okay. So information. Um we do this in a crazy so we're gonna do a fun state machine here, right? Um so we're gonna keep the plus, and then we're gonna add to it. Um test equals A100. Or gonna be P0. If this is true, if both these are true, P is 100. Let's just say move A1 into X3. See if that works. Okay, so restart. Let's step through this. Do I have to register those? That just seems crazy. Can you do I have to does it register or interrupt? Oh, we do have loops. Forgot about that. Ah. So we can dump dat. We already know what dat is, so move E0 into ACC. How would we do that? We would want to do like minus um I would say yeah, just do ACC plus move P1 into dat. Now we'll do test equals um so we get to we're gonna so we're gonna have to can't move store value, so we're gonna have to so as soon as we test a value, right, it's no longer useful. We're gonna test ACC. Test ACC equals 100, and the last thing we want to do is we're going to move ACC into 3. Ooh. But we haven't done that yet. We're going to transmit out of. You could just do minus and like do a jump to jump end, right? are we gonna have enough code space for all this crazy stuff we want to try? Right? So we could jump end. And then we just don't have to worry about that. And we request that. Then here we're going to have a move of ACC into 3. And now here we don't have enough lines. Do I need to have another processor just determine the stat states? Ugh. Ugh. We only have P registers too. I mean, really, but we don't have any just simulate, right? 0, 0, 0. I don't know what they expect. Parts are not recommended. Oh. So those parts aren't recommended. How can we do it? I'm thinking of how I could do this. And I mean, I want to keep it as simple. Let me just I do this. What happens? Um, and if I say can I test equals of 100, p 0. Okay. Oop. So if I step, 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 step. Okay, so apparently in that situation we can so um 100b. So let's do specifically this situation, right, where they're both. Um Okay, so hmm. Is there any way we can sneak by with 2 lines of code? I don't know. I don't know. We can sneak by with 2 lines of code. Um, what's the next one? It's a 2, right? Yeah. We kind of want to says his part not recommended though. It's kind of mean. Oh, these X buses are bidirectional. We could do that and just have something that's handling that. I don't really have an X bus splitter. We probably would want Chonky Boy to handle all those conditions. Uh, do X1 to X1. Uh, and the terrible naive approach. Let's see if we can get this done real quick. X0, X0. Um, so what we're going to do is basically we're gonna be like, hey, can we get data? And then we're gonna be like, thanks for sending it away. And same thing here, but X1, X1. And what we're going to say. Um, we don't really. You have to move it. You have to at least test. Okay, sure. Cool. I got what we want. We're gonna jump. Label not defined. Well, of course it's not defined. We gotta do this. Okay. We're just gonna move ACC. So we're default. We're just gonna move A0 into ACC. Then we have to check these conditions. 0, they're both 0. So now we're just gonna say pair, right? Um, if P oh no, let's do test equal, and then we can do a test compare on that thing. So I'm gonna test equal. But P0 100. So what we're saying here is equal to 100. We got that condition covered. Now we just gotta do this condition. I said we gotta do a test compare, right? It's a 0. Okay, so now so I think other way we overwrite it. So we do test equals P1 to 100. We want it to be false. Not the false statement. So 0 100. So 0 0 0. Now the point of that. Um I'm trying to have too much fun here, figuring out what we can get. Um, yeah, create like a little state machine that works well. Conditionals are a little confusing. So if it's zero, 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 and zero, true. We don't want it to be true. We want to move a 2 here. And if A is 100, be 0, we want to move a 1 ACC here. And then we gotta test, equivalence of P1 to 100. And if that is true, we want to move a 3 to ACC. Okay. Now, um, it's 0. Okay, so the issue here is I have no other fancy conditionals, right? We're only doing 2 conditionals, right? So um what we're saying is what we really want here is equal to 100. Not equal to 100. Skip. Let's try to create a skip. We have 2 values, and we're trying to get a third conditional of it. So it's not really going to work in that situation. Yeah, we're just gonna have to say 100, and then just put a minus here. Of moving a 0 into ACC. Ow. What are we getting at? Yes. Oh, okay. So what's happening here is this is true. We have another space, right? We could just put another conditional here, just reset it. And we just do, you know what? If P0 does equal 100, What does it really matter? And now, what does it really matter? Okay, cool. I can go to bed now, guys. Only 1 minute over. Ah, man. This is hard. And I want to do digital logic, but it's like part not recommended. So lines of code was really bad. Power usage was okay. And production cost was very expensive. So there's better ways to do this. I wish I was smarter than that. Hmm. Um, so yeah, I think that's going to be it for today. Thank you for watching. That was fun and intense. I'm gonna what was that thing called? Little Help. We're gonna go look at the wireless game controller, the cheat. So let's see. Shenzhen IO, a wireless game controller. Um, Math blog. Let's see. What was okay, he did use one of those. So he had a PP, X2 and X2. Okay, yeah, that makes sense. Move X2 into AC, subtract 8. Oh, is that like an adder? Yeah, oh. Um, it's greater than 8, subtract 8, send ACC. Okay, so let's go look at that real quick. I'm curious. So if we go back here and we open in CAD, open design, he's using the DX300. So I'm curious, what's the DX300 do? DX300. Um, so in here he's saying, oh, okay, so let's go back to that, right? P1, P2. And so okay. 1, 2. Uh, okay, yeah, it's not binary, it's weird values. But it's going binary to decimal. Okay, that's a neat little trick. Yeah, we should try some of the parts that are not recommended so that we can play around with it. But yeah, okay, that's a very interesting solution. Um, yeah, that would be very interesting. Okay, well, thank you for joining us. See us Friday for Vitus AI.